So diagram number 6 states that we need to have 2 single pole double throw switches, both to control the light socket. So like we did in the last video where we talked about the 3-way switches, kind of how these things work, we're going to go through and actually wire these things up within our diagram. Now, you should have watched the how to diagram number 1 and 2, done 3, 4, and 5 on your own, and now you should be at this point where you can take some of that information and actually use that to help further how we're going to actually do these. Couple things that we want to make sure that we keep in mind. Our source is always going to have the same 3 colors that are going to be in there. We're always going to have a hot wire. We're always going to have a neutral white wire. Neutral is represented by the yellow wire that we see. We don't have white, or white doesn't show up, so we don't do it. And then we are always going to have, the last one is our ground or green screw. Could be green, could be bare. They mean the same thing. So that's not going to change at all. That is the same from all of these diagrams through every single one. You are always going to have those 3 as our source wire in all of these diagrams that we're doing in class. Now, if you remember from wiring up and doing the stuff from the 3-way switches, there's really kind of a couple rules that if we follow, these things can be very, very simple. We're doing number 6. You are going to be working on 7, 8, and then 9 and 10 aren't necessarily the 3-way switches. They're a little bit different, but you should have enough information to be able to wire those up based on, after you go through this, you should be able to figure all that stuff out. So the way that we need to do this, and there's really kind of a couple ways that you can kind of attack this to make this maybe a little bit easier. One way that we can do this is wire up our neutral wires first. One of the biggest problems that we have is, are we going to use a white wire as a neutral or not? So, and you can do this in every single diagram. You can take that white wire represented by the yellow and connect all the neutral terminals. And how we do that, how we connect it, could vary. What we're going to do is we're going to just take our neutral wire from our source. We're going to carry it into this box. Is there any neutral terminals in here? The answer is no. If that's the case, we can wire that stuff up. We can carry these things onto this next box. We can ask ourselves the same question. Is there any neutral terminals in this box? The answer is no. There are no neutral terminals. And then we're going to carry this thing down into our light. We know that there's a neutral on our light. Every light socket is going to have a neutral. It has to carry that power back from our load. Same thing goes with an outlet. There needs to be a neutral. If we had switches beyond here, we wouldn't carry this neutral wire through because we wouldn't need it. It doesn't need to exist as a neutral. In this case, the way we have these things wired up, this neutral is wired up and does carry through. We are going to have nothing in these boxes. We're not going to wire in here. We're not going to put anything. All the wires need to be directed over and then down. That's where they need to go. That's what this diagram is kind of telling us we need to do. So if we do that, the only things that we really have to hook up are our grounds, which we'll do that last. Those things haven't changed, slightly different, but it's the same concept through every single one. The only thing that we need to figure out is our hot wires. Now, the rule of thumb when we are dealing with these switches is to connect your commons. What you need to do is connect one common to your source, the other common to your load. If you do that, 99% of your problems when hooking these things up are going to be solved. How do I know which common to connect to which thing? Well, my rule of thumb is whatever's closest. This common right here is closest to my source. That common is closest to my light. It doesn't make sense to crisscross things if they are closer. Now, sometimes one common is going to be closer to both the light and the source. Pick one to go to one and the other to go to the other. In this case, it's pretty simple. We're going to take one common. We're going to wire it up to our source here. We're going to take the other common. We're going to wire it to our light there. The only thing that we have left to do on these 3-way switches is to simply connect these traveler wires. I'm going to connect this brass to the same brass on the other side and this brass to that brass on the other side. Now I could do this where I connect, and let's say I go a black wire here and I do a black wire here. The issue that I run into with this is now between these two boxes, I have two red wires. This line is or two black wires. This line is touching two of those things. So we're going to go ahead and get rid of that other wire. We can't use a white wire as a hot because I already have a white wire being used as a neutral. So that's where our red wire is going to come in to serve as an additional hot. So now we have a black, a white, and a red. One thing that we want to make note of, this is in between where there's no conduit. So this box is going to need to use a 14-3 Romex. It needs to have those three colors in there. This one follows that through. This is just going to be a 14-2. We don't have any other connections. Remember, these are designed to carry on. If I had another light, if I put another light right here, I can connect black wires, white wires to those, and I can carry that on. So that way these two switches can control two lights. You might have two lights in your hallway. This could control one light or a bank or set of lights. And those things are just designed to carry on. From this point on, we have our commons correct. If we were to flip a switch, it's going to turn on or off that light. This will work. It is not safe. That's where the ground wires come in. So, oh, that's not a ground wire. That's a ground wire. So just like all our other diagrams, you're going to wire nut. We're going to pigtail to those two ground terminals. We're going to take the ground that's coming into here. We're going to wire nut, represented by this little box. We're going to pigtail those. This does not connect to that green screw. We only connect one wire per screw. So it's not actually touching that. So make note of that. We just made an error. We could change that and say, okay, let me do this and go up and over. And if it doesn't have a wire nut, these wires aren't actually touching either. And then this one's going to come down. We can simply wire this down to that bottom there. And now every green screw is there. Where our wires are connected, our commons are connected. This is how we do a three-way switch. Again, you guys are going to work on 7 and 8, which are two different forms of it. It's the same equipment, different orders. How we wire it is slightly different. Keep in mind the commons. One goes to your source, the other goes to your load. If you can do that, you're going to solve most of your problems there. Carry your neutrals back. If they're not being used as a neutral, you may use them as a hot. If we were to mark these as a hot, it's important that you would mark it here, 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 and there. These are not, so you're not going to mark them, but you would do that. Okay, so don't actually mark it on this diagram. Those are neutral wires. So we're going to get rid of them. This is the final design. This is kind of what we should have.